Now that I've given away all the answers to the final, don't tell the people that did this. Now that I've given away the answer to the final, remember that we're looking at graphs of sine and cosine, and the changes to the graph that changes to the functional half. All we're doing is adding operations before and after the trig function. The operations we care about are multiplication and addition. And so I have 4 things that I want to look at. Multiplication before the trig function, multiplication after with B and A. I want to look at addition before and addition after. That's the C and the D. So let's review our default states. The graph of cosine and sine. This is with an A and a B of 1. The multiplication default state is 1, because multiplying by 1 doesn't do anything. So A is 1, B is 1. That's no changes through multiplication. And also adding 0 doesn't do anything. So C and D are going to be 0 in our default state because we have no changes. 1 represents no change through multiplication. 0 represents no change through addition. So those are our default values for multiplication and addition. If we just have cosine and cosine x and y equals sine x, our amplitude was 1. The middle was at 0. The period was 2 pi. And cosine started at the top when x is 0. Sine started at the middle going up when x equals 0. Remember, our sequence of points was top, middle going down, bottom, middle going up, repeat. Also remember that each of these is 1/4 period apart. Each of those points is 1/4 period apart. It's 1/4 period because 1 period is going around the circle 1 time. Each of these represent what's going on at one of the quadrant angles. Question? So we want to examine what happens when we multiply and add before and after. 4 things for us to consider. What happens to the amplitude, the middle, the period, and the starting point. So to do that, we're going to go over to a graphing calculator and just change some of these values. So let's hop over to Desmos and see what changing these values what effect changing these values has. So here we have a graph of cosine in orange and sine in green. It's October. So I'm just going to use some nice October looking colors. And I have set up a cosine and a sine with the 4 things I'm interested in changing. I've got A, B, C, and D in my cosine and sine corresponding to the same A, B, C, D that I had in the setup. Also, I have set A, B, C, and D to their default values. And we're just going to start changing these values and see and describe what happens to the function. Describe what happens to the graph of the function. Now, while we're looking at these graphs, we can see that at the top, we've got a top of 1, at the middle is at 0, and the bottom is at -1. I'm looking at the y values for anything vertical. Also notice that if I keep going and back to the middle and back up at the top, that from 0 to 2 pi, that's one cycle. We go from the top point to the next top point, and we see one cycle. Also notice that the orange is cosine and it starts at the top. For the sine, one cycle is at the middle going up, then the top, the middle going down, the bottom, then the middle going up. The top is still at 1, the middle is at 0, the bottom is at -1, the period is 2 pi. So if I go back to the previous point that was at a middle going up, that will be at -2 pi. So just like with a cosine, here we start off at x equals 0. We're back to the start at the top at 0 at 1. Then 2 pi units later, 1's period later, we're at 1 again. If we go to the period before, the place before that, -2 pi, that's where we're at 1. There's one cycle from top to top, 2 pi units. All we need to do now is put these values in motion and describe what's going on. Let's put A into motion. So I've set this up to just bounce back and forth from -4 to 4 with a step of 0.2. So it started off at 0. Started off at 1. Sorry, that's the default. Started off with the default 1, and then it started going up by 0.2 to 1.2, and so on. So hit play. What is changing about the graph? Of the things that we pointed out on the graph, there were 4 things: amplitude, middle, period, and start. What's changing when the value of A changes? Yes. Looks like the amplitude is changing. Is the middle changing? No. Is the period changing? No. How about the start? How is the start changing? What's going on? Take a look at the difference between this graph and now. What happened? What's weird about this picture from where we started? Where is cosine when x is 0 in this picture? So notice that when x is 0, what would we call that point in our sequence of points? Here we are at the bottom. But then a little bit later, so it's at the, now it's like the 0 is at the bottom, but now the 0 is at the top again. Here's the 0 at the top. Now it's all flat. And then the 0 is at the bottom again. What's going on? What's happening? What's changing to make our our start go from the top to starting at the bottom? When A goes negative, it looks like the graph gets flipped over. When A becomes negative, it looks like the cosine is starting at the bottom. A is also negative. Let's look at the sign. Now, when A is positive, cosine starts at the top, sine starts at the middle going up. See the middle going up. But when A drops negative, cosine is starting at the bottom. And where is the sine? It's at the middle, but which direction? Remember, there are 2 middles. There's a middle going up and a middle going down. So now, when A is negative, sine is starting at the middle going down. So we notice that there are 2 things that are happening here. When we change the value of A, we're changing the amplitude. And when A is negative, it like flips what we consider the start. When A is negative, cosine starts at the bottom, sine starts at the middle going down. That's like the opposite. So it looks like A influences two different things. So that's just us looking at this experiment. Let's go summarize what we found. So first thing we notice is that changing A changes the amplitude. Changing A changes the amplitude, has no effect on where the middle is, because the middle was at 0 the whole time, has no effect on the period. When A went negative, we went to the opposite of the start. Instead of the top, we start at the bottom, or instead of the middle going up, we start at the middle going down. When A is negative, we use the opposite starting point. So we can summarize that. We'll say that the positive cosine is the top, negative cosine starts at the bottom, positive sign is middle going up, negative sign, middle going down. Positive cosine is the top, negative cosine is the bottom, positive sign is the middle going up, negative sign is the middle going down. But changing A had no effect on the period or the middle or the 0. It looks like A had no effect on the middle, the 0, or the period. How's everybody okay? Everybody looks stunned. Oh, wow. Change the amplitude. It even starts with A. That's why we start with this one. But then you're like, oh, wait, period does not start with B, C, or D. Let's head back to our graph. So our default value for A is 1. And then the top was at 1. And that made the bottom at -1. Different x's for sine and cosine. Well, that's all right. The top was at 1. The bottom was at negative. If we change the value of A, when A went up, the top went up and the bottom went down. So if I change A to 3, let's take a look at where the top is. We can see that it's gone up. And we notice that the top is at 3 and that the bottom is at -3. And the middle is still the middle, 0. Moreover, it looks like whatever the value of A is, that's going to be our amplitude. Unless A is negative. If A is -3, then the top is at 3 still, and the bottom is at -3, and the middle is still at 0. Here's the bottom is -3, top is 3, middle is 0. So when A is -3, the top is 3, the bottom is -3, the middle is still 0. Still no effect on the middle. So it looks like whatever A is, the value of A, the absolute value of A is the amplitude. So it looks like the absolute value of A is the amplitude. When A is 3, amplitude is 3. When A is -1.2, amplitude is 1.2. Amplitude is always a positive value because it's always distance. There's the top at 1.2. Here's the bottom at -1.2. So even more detail, changing A changes the amplitude. The absolute value of A is the amplitude. The negative just tells us whether we're going to start at the top, or the bottom, or the middle going up, or the middle going down. I forgot to share screen. While I'm recapping this in share mode, so we can see it in the recording. So when A is 3, our top is at 3, the bottom is at -3. Notice that the middle is at 0. Remember the kind of change we're making. We're multiplying by 3. If the middle is at 0, when we multiply all those zeros by 3, we come up with 0 times 3, still 0. Multiplying by 0, everything becomes 0. So nothing changes when I multiply the zeros by 3. So I'm multiplying everything by 3. That includes multiplying by 0, but that doesn't change where those points are. And when A drops to -3, the top is still at 3, and the bottom is at -3. And the 0 doesn't change, because multiplying 0 by 3 doesn't change. Any questions? Comment? That's what A does. A is telling us the amplitude. The absolute value of A is telling us the amplitude. The sign of A is telling us whether to use the regular start, top or middle going up, or the negative start, bottom, middle going down. It even matches up. Top is positive, middle going up is positive, bottom is a negative, middle going down is a negative. It's almost like we set this up to work this way. Okay. Now, it would make a lot of sense if the next thing I do is just move on to changing the values of B. So let's not do that. Let's see what happens if we change the value of D, because D is happening after the trig function. And A, just like A happened after the trig function. So rather than looking at multiplication before, I have to pick one direction to go. I either stay with the same operation or I stay with the same side of the trig function. I'm going to stay with the same side of the trig function. So let's jump over to our graph again. Let's put A back to our default. And let's put the value of D in motion. So D is the other operation that's happening after the trig function. So as the value of D changes, what is happening? What is changing? Is the amplitude changing? No, we just decided that amplitude was controlled by the value of A. Amplitude is staying the same because the height of the graph is the same as D goes up and down. Is the period changing? No, we can see that the top points are staying the same distance apart. They're staying 2 pi units apart. What about the start? What's going on at 0? Is the cosine changing? The 0 point seems to always be at the top on the cosine and at the middle going up. So the start point isn't changing. What is changing? Let's freeze it. Big money, no whammies, pause. So here, this top point is at 3.8. The bottom point is at 1.8. Not going to let me land on it. Gonna let me land on it. Wow. Rats. What am I trying to land on? I'm trying to land on 3 and it's not letting me. Oh, it's being Desmos, you're being a jerk. It's like, well, it's happening at an irrational point. How you like me now? There we go. So what is changing when we change the value of D? What did we call that? The mid. The middle is changing. The amplitude isn't changing. Notice that blue line is now at the middle. The distance from the middle to the top, that's always going to be 1, with A is equal to 1. The middle to the bottom, that's also 1. What's changing is where the middle is. The middle keeps moving up and down. So changing D changes where the middle is. Moreover, since that blue line is just the flat line where Y is equal to D, it looks like whatever the value of D is, that's where the middle is. Changing D changes where the middle is. D is the middle. Changing D changes the middle. Moreover, the middle is just whatever D is. So that's a nice, easy change. Whatever D is, that's the middle. D has no effect on the amplitude, the 0 of the start, or the period, or the location of the start. value of D did not have an effect on the amplitude. That's it. That's A's job. Didn't have the zero effect on the zero at the start, the starting point itself, or the period. D is about the middle. What we want to notice is that A and B are both vertical things. The middle is changing vertically, and the amplitude is changing vertically. A and D are vertical changes. When we placed operations after the trig function, we produced vertical changes in the graph. So A and D are operations that took place after the trig function, and they produce vertical changes in the graph. You might think this is coincidence, but if it was coincidence, I would have just said this is coincidence and not made it such a show of writing down vertical changes, only to have to erase it afterwards. Whatever we're getting out of the trig functions, the trig functions are setting up a bunch of y values. I'm doing stuff after those y values are set up. I'm going to make vertical changes in the graph. What do you think is going to happen with B and C? I've read some of your minds. It's horizontal changes. If you were not guessing horizontal changes, you were thinking that I'm trying to trick you in some fashion, but I would never do that. Of course, if I was going to try to trick you in some fashion, I would say I was never going to trick you in some fashion. I guess you're just going to have to trust me. Proof by trust in your professor. Trust me. I wouldn't lie to you. Proof by intimidation. Proof by authority. You can trust me. I'm the instructor. Proof by intimidation. You better trust me. I'm your instructor and I can flunk you. Let's take a break, come back and examine the horizontal changes that will happen with multiplying by B and subtracting C.